Students, welcome to today's session. In today's class, I'll be explaining you about classification of control systems. So this tree structure is showing you the classification of control system. Control system is basically classified into natural and man-made control system. Natural control systems are those systems which are not made by a human being. Man-made control systems are those which are made by a human being. Again, man-made control systems are further classified into manual and automatic control systems. Manual control systems are those where the controlling action needs an human interference, whereas automatic control system is one wherein the controlling action is done without the human interference. And further, again, this automatic control system is classified into open loop and closed loop control system. Open loop control systems are those systems which does not have any feedback, whereas closed loop control systems are those which have a feedback. So based on the feedback which is available, the systems are further classified as open loop and closed loop control systems. And again, based on these properties of systems, open loop and closed loop systems are further classified as non-linear control system, linear control system, and similarly closed loop systems are also classified as non-linear and linear control systems. Further, this non-linear and linear control systems are classified as time variant and time invariant based on the variation of the output with respect to the input. And similarly, linear control systems are also classified as time variant and time invariant. So the systems which are man-made, automatic, closed loop and linear and time invariant are termed as LTI control system. LTI stands for linear time invariant control system. So let's take up this group of control systems one by one with examples. The first basic type of control system what we saw was natural control system. So natural control systems are not man-made control systems, they are built naturally. Few examples which we can quote for a natural control system is universe and human body. So as we know, universe is not man-made, it's a control system wherein we have the sun surrounding different planets which rotate in a particular controlled manner. So this is also an example of a natural control system. The second natural control system which is available in nature is our human body itself. So we can correlate human body to be a natural control system because the brain here acts as a controller, okay, so which is going to control the other organs of the body. So based on the feedback signals sent from the brain, the other organs of the body work in a controlled manner. So these two can be quoted as an example of a natural control system. Similarly, the ecosystem what we have is also an example of a natural control system. Now coming to man-made control systems, all the devices, whatever it is made from a man or a human being is considered to be a man-made control system. So two examples which I've quoted here includes aeroplane and chemical process. Okay, so all the devices, most of the devices which we are using are all will come under man-made control system. Now coming to manual control systems. Manual control systems are those control systems which is controlled by a human interference. So here as an example we can consider the room temperature regulation via an electrical fan. So here everybody we know that we will be using the electric fans, right? So controlling action of an electric fan always needs an human interference. So the speed of the electrical fan can be changed by using a human interference. So you can have automatic electric fans also, wherein you will have a remote to control the speed. So but an electric fan commonly controlled by a regulator can be considered as a manual control system. Similarly, a water level controller, which is not automatic, also could be taken as an example of a man manual control system. Your mixer, grinders, everything will come under this category. Whereas coming to automatic control systems, these are the control systems where the controlling action is done automatically without the human interference. So example for this which we can quote is home water heating system, that is your geysers which we'll be using regularly in our day-to-day life, is an automatic control system where the geyser is going to switch off once the water gets heated to the desired temperature. Okay, and similarly room temperature regulation via air conditioner, which is also an automatic control system, and human body temperature control could be considered as an example of an automatic control system. Now these two control systems are very important, and we can expect one question on this, that is open loop and closed loop control system. So the systems are basically classified as open loop and closed loop control system based on the feedback which is available. Open loop control systems are those control systems which utilizes a controller or a control actuator to obtain a desired output. Here the output doesn't have any effect on the control action. So that means we do not have any feedback from the output. So in other words, we can say that the output is neither measured nor fed back. A normal control system within controller, process, input and output forms an open loop control system. So as you can observe here, we have an input which is given to a controller. The controller will give the controlling signal to the process where the actual process will be carried out, and we are going to get the output. So this is the working action of a open loop control system. Quoting few examples, a washing machine, a toaster, electric fan, microwave oven could be considered as an example of open loop control system. As you can see in washing machine, once we put the cloths inside, okay, and we start the machine, so till the job gets over, it won't stop. So you will feed the cloths and you will get the washed cloth, that's it. Okay, so over here there is no feedback which is given to a controller. Okay, similarly toaster, once we put the bread here inside, setting the temperature, that is done, you will get the toasted bread as an output here. So there is no, again here there is no feedback. And electric fan also, so once the speed is set, you cannot change it. So based on the temperature, we cannot adjust the speed of an electric fan, and so on. So like this, we have a number of examples for open loop control system which we can quote. Now here, since the open loop control system doesn't reference input is not compared with the measure output, so for each of the reference input there is a fixed operating condition. Therefore the accuracy of this open loop control system basically depends upon the calibration. So to maintain the performance of an open loop control system, always calibration is required, and the performance of an open loop control system is severely affected by the presence of the disturbance or variations in the operating or environmental conditions. So these systems are always prone to disturbance. Now coming to the advantages of open loop control system. Open loop systems are very simple and economical, and they are easy to construct. Because of this easy of construction, they are economical and they are considered to be stable. So these are the main advantages of open loop control system. Coming to disadvantages of open loop system, the open loop systems are inaccurate because there is no feedback and unreliable sometimes. And also the changes in the output due to external disturbance are not corrected automatically. And the third disadvantage is to maintain the quality and accuracy, recalibration of the controller is necessary time to time. So these are the three main disadvantages that we can come across in the implementation of an open loop control system. Now coming to closed loop control system, as we can refer the block diagram of a closed loop control system. So we have a controller, plant, process. Along with that we have a feedback from the output, which is given as an input for a comparator or an error detector. These two are the extra elements present in a closed loop control system. The closed loop control system utilizes the feedback to compare the actual output to the desired output reference. So feedback is present in closed loop control system. So here a part of the output is fed back as an input for the uh, error detector or the comparator. Now based on the comparison, your comparator checks whether the desired output is obtained or not. If we are unable to get the desired output, then it sends a message to the controller to give a control signal for the plant or the process to generate the desired output. For example, if I consider a heating system, if my desired temperature is, for example, it is 60 degree, and if my output what I've got here is, for example, 50 degrees, then this output is fed back to the comparator or the error detector, which has a reference value, that is the desired output value that we need to achieve from the output. So comparison will be done with the temperature, desired temperature, which is nothing but the reference temperature, with the actual temperature what we have got. Now for example, if the difference what we have got is the output is 50 degree, the expected output is 60 degree. Now this error detector compares the temperature, desired temperature, with the actual temperature which is obtained, and the difference in the temperature is around 10 degree. So it tells the controller that the desired temperature is not achieved. So there is a difference of 10 degrees centigrade, and the controller sends a necessary signal to the plant or the process to increase the temperature by 10 degrees centigrade to obtain the desired output. So this is how a closed loop system with feedback works. So to quote examples for this control system, we can take an example of a refrigerator where the temperature will be adjusted automatically, and electric iron box, air condition, all these could be taken as an example for closed loop control system, where a feedback is taken and based on that the temperature is getting adjusted. Now coming to advantages of closed loop control system, closed loop systems are accurate. They are accurate even in the presence of non-linearity, and they are more stable when considered with open loop control system. They are less affected by noise, and bandwidth of operation is very high. Disadvantage of closed loop control systems are they are complex and expensive. Feedback in closed loop system may leave oscillatory response, and more care is needed to design a closed loop system. The overall gain of the system is reduced due to feedback. So these are the disadvantages of closed loop system. Coming to comparison, so this is one of the important question which might be asked in the examination for 6 marks. So they'll ask you to compare open loop control system with closed loop control system. So the few parameters are considered here for the comparison, and it is listed in the table. The first parameter is construction and design are simple and less expensive in case of open loop control system, whereas the design is complicated and more expensive in terms of closed loop control system. And coming to stability, generally the stability is not a problem in case of open loop control system, but here in case of closed loop control system, designers should be careful, as there is a tendency for less stability sometimes. And open loop control systems are considered to be less accurate and less reliable, whereas closed loop control systems are high accurate and more reliable. Coming to feedback, we do not have a feedback in open loop control system. Output doesn't have any effect on the input. Whereas in the case of closed loop control system, feedback is present and output affects the input. And open loop control systems are sensitive to disturbance and environmental changes, whereas closed loop control systems are insensitive to environmental changes. Coming to bandwidth of operation, open loop systems have smaller bandwidths, whereas closed loop systems have larger bandwidths. And non-linearities affects the response of the output in open loop system, whereas non-linearities does not affect the response in case of closed loop control system. So this is about the comparison of open loop and closed loop control systems. The next category of control systems are multivariable control systems, where we will have multiple inputs for the comparator. As you can see here in this particular system, we are taking three variables, input variables, that is temperature, humidity and pressure for comparison. Okay, so this is a feedback control system where a feedback is taken from the output and a multiple inputs are considered here for the comparison. So such type of systems are termed as multivariable control systems. Now coming to the other type of control system, linear and non-linear control systems. So a control system is said to be linear if the output varies linearly with the input. Such systems are called as linear control systems. So there should be a linear relationship between input and output. So an example is given here for linearity and non-linearity. So y of t equal to minus 2 u of t plus 1. Here y of t is taken as 3 into u of t plus 1. The first one is considered to be non-linear. The second one is considered to be linear control system. So the systems which satisfy the linearity condition are said to be linear control system, and the system which does not satisfy this condition is said to be non-linear. So here a response is given where the input and output have non-linear relationship and the system is said to be non-linear. So there is no linear relationship. Here there is a variation. So the output is not varying linearly with the input. Now coming to time variant and time invariant control system. So time variant systems are those systems where the output changes with the change in the time. For time varying control systems, the output parameter varies with time. Whereas in case of time invariant control system, the output does not vary with the time. So examples are given here: y of t equal to minus 2 u of t plus 1. Here since there is no time variable t, the system is said to be time invariant. Here in the second example, if you can see, y of t is taken as 2 into u of t, where u is your input, into minus 3t. So here I have the time variable t, so the output is changing with respect to the time t. So such systems are said to be time variant. Now coming to the next type of control systems, continuous data versus discrete data systems. So in continuous data control systems, all system variables are functions of continuous time t. That means you will have a value of an output for all instance of time t. Whereas a discrete control system involves one or more variables that are known at discrete time intervals. So we will have a value only at particular instance of time t. So based on the control system data, the systems could be classified as continuous data and discrete data systems. Next, deterministic versus stochastic control system. A control system is deterministic if the response of an input is predictable and repeatable. So if we can determine what is the output response for the input given in a proper way, then we can say that it is a predictable system or it is a deterministic system. So if you can see here, if x of t is a triangular waveform which I am giving, if I am getting y of t as a square signal like this, which is deterministic, then the system is said to be deterministic control system. So if, for example, if I am giving some input, if the output response is not at all predictable, if it is taking some other shape like this which cannot be determined, then such systems are said to be stochastic control system, where you cannot determine the output of a system even if you know the input. So it is very difficult to judge the response of a stochastic control system. So these are few examples of control system: a water level float regulator, and an example of another control system where a manual control system where a person is controlling the level of a fluid in a tank by adjusting the output valve. So this is an example of an control system which is not automatic, it is manual control system, whereas the other example which I showed you in the previous slide is an example of a automatic control system. So in today's session we have discussed about the basic classification of system. So just let me review the concepts what we have discussed today. In the classification part, basic classification we have taken was, the first basic classification is natural and man-made control system based on the category, that is whether it is built by a man or whether it is built naturally. We have classified as natural and manual control systems, and we have quoted examples for this also. And again, in man-made control systems, the systems are classified as manual and automatic. Okay, and again, automatic control systems are further classified as open loop and closed loop control system based on the feedback from the output. So open loop control system does not have a feedback from the output, whereas the closed loop control system have a feedback from the output. And again, this open loop and closed loop systems are further classified as linear and non-linear based on the relationship between the input and output. And again, this linear and non-linear control systems are further classified as time variant and time invariant control system based on whether the output varies with respect to the time or it does not vary with respect to the time. And again, based on the data which is available from the system, systems are further classified as continuous data control systems and discrete data control systems. And based on the type of the output response what we can expect from the system by giving the corresponding input, the systems are classified as deterministic and stochastic control systems. I hope today's session was informative and you are able to get the basic concepts about control system and the classification of control system based on their properties. Thank you one and all. Have a nice day.